In this section, you're going to learn about machine learning, which is a subset of AI or artificial intelligence. It's one of the trending topics in the world these days, and it's going to have a lot of applications in the future. Here's an example. Imagine I ask you to write a program to scan an image and tell if it's a cat or a dog. If you want to build this program using traditional programming techniques, your program is going to get overly complex. You will have to come up with lots of rules to look for specific curves, edges, and colors in an image to tell if it's a cat or a dog. But if I give you a black and white photo, your rules may not work. They may break. Then you'll have to rewrite them. Or I may give you a picture of a cat or a dog from a different angle that you did not predict before. So solving this problem using traditional programming techniques is going to get overly complex or sometimes impossible. Now, to make the matter worse, what if in the future I ask you to extend this program such that it supports 3 kinds of animals: cats, dogs, and horses? Once again, you'll have to rewrite all those rules. That's not going to work. So machine learning is a technique to solve these kind of problems. And this is how it works. We build a model or an engine and give it lots and lots of data. For example, we give it thousands or tens of thousands of pictures of cats and dogs. Our model will then find and learn patterns in the input data, so we can give it a new picture of a cat that it hasn't seen before and ask it, is it a cat or a dog or a horse? And it will tell us with a certain level of accuracy. The more input data we give it, the more accurate our model is going to be. So that was a very basic example. But machine learning has other applications in self-driving cars, robotics, language processing, vision processing, forecasting things like stock market trends and the weather, games, and so on. So that's the basic idea about machine learning. Next, we'll look at machine learning in action. A machine learning project involves a number of steps. The first step is to import our data, which often comes in the form of a CSV file. You might have a database with lots of data. We can simply export that data and store it in a CSV file for the purpose of our machine learning project. So we import our data. Next, we need to clean it. And this involves tasks such as removing duplicated data. If we have duplicates in the data, we don't want to feed this to our model because otherwise our model will learn bad patterns in the data and it will produce the wrong result. So we should make sure that our input data is in a good and clean shape. If there are data that is irrelevant, we should remove them. If they're duplicated or incomplete, we can remove or modify them. If our data is text-based, like the name of countries or genres of music or cats and dogs, we need to convert them to numerical values. So this step really depends on the kind of data we're working with. Every project is different. Now that we have a clean data set, we need to split it into 2 segments, one for training our model and the other for testing it, to make sure that our model produces the right result. For example, if you have 1,000 pictures of cats and dogs, we can reserve 80% for training and the other 20% for testing. The next step is to create a model, and this involves selecting an algorithm to analyze the data. There's so many different machine learning algorithms out there, such as decision trees, neural networks, and so on. Each algorithm has pros and cons in terms of accuracy and performance. So the algorithm you choose depends on the kind of problem you're trying to solve and your input data. Now, the good news is that we don't have to explicitly program an algorithm. There are libraries out there that provide these algorithms. One of the most popular ones, which we're going to look at in this tutorial, is scikit-learn. So we build a model using an algorithm. Next, we need to train our model. So we feed it our training data. Our model will then look for the patterns in the data. So next, we can ask it to make predictions. Back to our example of cats and dogs, we can ask our model, is this a cat or a dog? And our model will make a prediction. Now, the prediction is not always accurate. In fact, when you start out, it's very likely that your predictions are inaccurate. So we need to evaluate the predictions and measure their accuracy. Then we need to get back to our model and either select a different algorithm that is going to produce a more accurate result for the kind of problem we're trying to solve, or fine-tune the parameters of our model. So each algorithm has parameters that we can modify to optimize the accuracy. So these are the high-level steps that you follow in a machine learning project. Next, we'll look at the libraries and tools for machine learning. In this lecture, we're going to look at the popular Python libraries that we use in machine learning projects. The first one is NumPy, which provides a multi-dimensional array. Very, very popular library. The second one is Pandas, which is a data analysis library that provides a concept called data frame. A data frame is a two-dimensional data structure similar to an Excel spreadsheet. So we have rows and columns. We can select data in a row or a column or a range of rows and columns. Again, very, very popular in machine learning and data science projects. The third library is Matplotlib, which is a two-dimensional plotting library for creating graphs and plots. The next library is scikit-learn, which is one of the most popular machine learning libraries that provides all these common algorithms like decision trees, neural networks, and so on. Now, when working with machine learning projects, we use an environment called Jupyter for writing our code. Technically, we can still use VS Code or any other code editors, but these editors are not ideal for machine learning projects because we frequently need to inspect the data, and that is really hard in environments like VS Code and Terminal. If you're working with a table of 10 or 20 columns, visualizing this data in a terminal window is really, really difficult and messy. So that's why we use Jupyter. It makes it really easy to inspect our data. Now, to install Jupyter, we're going to use a platform called Anaconda. So head over to anaconda.com/download. On this page, you can download Anaconda distribution for your operating system. So we have distributions for Windows, Mac, and Linux. So let's go ahead and install Anaconda for Python 3.7. Download. All right, so here's Anaconda downloaded on my machine. Let's double click this. All right, first it's going to run a program to determine if the software can be installed. So let's continue. And once again, continue, continue. Pretty easy. Continue one more time. I agree with the license agreement. Okay. You can use the default installation location, so don't worry about that. Just click install. Give it a few seconds. Now, the beautiful thing about Anaconda is that it will install Jupyter, as well as all those popular data science libraries like NumPy, Pandas, and so on. So we don't have to manually install this using pip. All right, now as part of the next step, Anaconda is suggesting to install Microsoft VS Code. We already have this on our machine, so we don't have to install it. We can go with continue and close the installation. Now, finally, we can move this to trash because we don't need this installer in the future. All right, now open up a terminal window and type Jupyter with a Y space notebook. This will start the notebook server on your machine. So enter. There you go. This will start the notebook server on your machine. You can see these default messages here. Don't worry about them. Now it automatically opens a browser window pointing to localhost port 8888. This is what we call Jupyter Dashboard. On this dashboard, we have a few tabs. The first tab is the Files tab, and by default, this points to your home directory. So every user on your machine has a home directory. This is my home directory on Mac. You can see here we have a desktop folder as well as documents, downloads, and so on. On your machine, you're going to see different folders. So somewhere on your machine, you need to create a Jupyter notebook. I'm going to go to desktop. Here's my desktop. I don't have anything here. And then click New. I want to create a notebook for Python 3. In this notebook, we can write Python code and execute it line by line. We can easily visualize our data, as you will see over the next few videos. So let's go ahead with this. All right, here's our first notebook. You can see by default, it's called Untitled. Let's change that to Hello World. So this is going to be the hello world of our machine learning project. Let's rename this. Now, if you look at your desktop, you can see this file, helloworld.ipynb. This is a Jupyter notebook. It's kind of similar to our Py files where we write our Python code, but it includes additional data that Jupyter uses to execute our code. So back to our notebook, let's do a print hello world. And then click this run button here, and here's the result printed in Jupyter. So we don't have to navigate back and forth between the terminal window. We can see all the result right here. Next, I'm going to show you how to load a dataset from a CSV file in Jupyter. All right, in this lecture, we're going to download a dataset from a very popular website called Kaggle.com. Kaggle is basically a place to do data science projects. So the first thing you need to do is to create an account. You can sign up with Facebook, Google, or using a custom email and password. Once you sign up, then come back here on Kaggle.com. Here in the search bar, search for video game sales. This is the name of a very popular data set that we're going to use in this lecture. So here in this list, you can see the first item with this kind of reddish icon. So let's go with that. As you can see, this data set includes the sales data for more than 16,000 video games. On this page, you can see the description of various columns in this data set. We have rank, name, platform, year, and so on. So here's our data source. It's a CSV file called vgsales.csv. As you can see, there are over 16,000 rows and 11 columns in this data set. Right below that, you can see the first few records of this data set. So here's our first record. The ranking for this game is 1. It's the Wii Sports game for Wii as the platform, and it was released in year 2006. Now, what I want you to do is to go ahead and download this data set. And as I told you before, you need to sign in before you can download this. So this will give you a zip file, as you can see here. Here's our CSV file. Now I want you to put this right next to your Jupyter notebook. On my machine, that is on my desktop. So I'm going to drag and drop this onto the desktop folder. Now, if you look at the desktop, you can see here's my Jupyter Hello World notebook. And right next to that, we have vgsales.csv. With that, we go back to our Jupyter notebook. Let's remove the first line and instead import pandas as PD. With this, we're importing pandas module and renaming it to PD, so we don't have to type pandas dot several times in this code. Now let's type PD dot read underline CSV and pass the name of our CSV file. That is vgsales.csv. Now, because this CSV file is in the current folder right next to our Jupyter notebook, we can easily load it. Otherwise, we'll have to supply the full path to this file. So this returns a data frame object, which is like an Excel spreadsheet. Let me show you. So we store it here, and then we can simply type df to inspect it. So one more time, let's run this program. Here's our data frame with these rows and columns. So we have rank, name, platform, and so on. Now, this data frame object has lots of attributes and methods that we're not going to cover in this tutorial. That's really beyond the scope of what we're going to do. So I leave it up to you to read Pandas documentation or follow other tutorials to learn about Pandas data frames. But in this lecture, I'm going to show you some of the most useful methods and attributes. The first one is shape. So shape, let's run this one more time. So here's the shape of this data set. We have over 16,000 records and 11 columns. Technically, this is a two-dimensional array of 16,011. Okay. Now, you can see here we have another segment for writing code. So we don't have to write all the code in the first segment. So here in the second segment, we can call one of the methods of the data frame, that is df.describe. Now, when we run this program, you can see the output for each segment right next to it. So here's our first segment. Here we have these 3 lines, and this is the output of the last line. Below that, we have our second segment. Here we're calling the describe method. And right below that, we have the output of this segment. So this is the beauty of Jupyter. We can easily visualize our data. Doing this with VS Code and terminal windows is really tedious and clunky. So what is this describe method returning? Basically, it's returning some basic information about each column in this data set. So as you saw earlier, we have columns like rank, year, and so on. These are the columns with numerical values. Now, for each column, we have the count, which is the number of records in that column. You can see our rank column has 16,598 records, whereas the year column has 16,327 records. So this shows that some of our records don't have the value for the year column. We have null values. So in a real data science or machine learning project, we'll have to use some techniques to clean up our data set. One option is to remove the records that don't have a value for the year column, or we can assign them a default value. That really depends on the project. Now, another attribute for each column is mean. So this is the average of all the values. Now, in the case of the rank column, this value doesn't really matter, but look at the year. So the average year for all these video games in our data set is 2006. And this might be important in the problem we're trying to solve. We also have standard deviation, which is a measure to quantify the amount of variation in our set of values. Below that, we have min, As an example, the minimum value for the year column is 1980. So quite often when we work with a new data set, we call the describe method to get some basic statistics about our data. Let me show you another useful attribute. So in the next segment, let's type df.values. Let's run this. As you can see, this returns a two-dimensional array. This square bracket indicates the outer array, and the second one represents the inner array. So the first element in our outer array is an array itself. These are the values in this array, which basically represent the first row in our data set. So the video game with ranking 1, which is called Wii Sports. So this was a basic overview of Pandas data frames. In the next lecture, I'm going to show you some of the useful shortcuts of Jupyter. In this lecture, I'm going to show you some of the most useful shortcuts in Jupyter. Now, the first thing I want you to pay attention to is this green bar on the left. This indicates that this cell is currently in the edit mode, so we can write code here. Now, if we press the escape key, green turns to blue, and that means this cell is currently in the command mode. So basically, the activated cell can be either in the edit mode or the command mode. Depending on the mode, we have different shortcuts. So here we're currently in the command mode. If we press H, we can see the list of all the keyboard shortcuts. Right above this list, you can see macOS modifier keys. These are the extra keys that we have on a Mac keyboard. If you're a Windows user, you're not going to see these. So as an example, here is the shape of the command key. This is Control, this is Option, and so on. With this guideline, you can easily understand the shortcut associated with each command. Let me show you. So here we have all the commands when a cell is in the command mode. For example, we have this command, open the command palette. This is exactly like the command palette that we have in VS Code. Here's a shortcut to execute this command. That is Command, Shift, and F. Okay, so here we have lots of shortcuts. Of course, you're not going to use all of them all the time, but it's good to have a quick look here to see what is available for you. With these shortcuts, you can write code much faster. So let me show you some of the most useful ones. I'm going to close this. Now, with our first cell in the command mode, I'm going to press B, and this inserts a new cell below this cell. We can also go back to our first cell, press Escape. Now the cell is in the command mode. We can insert an empty cell above this cell by pressing A. So either A or B. A for above and B for below. Okay? Now, if you don't want this cell, you can press D twice to delete it. Like this. Now, in this cell, I'm going to print a hello world message. So, print hello world. Now, to run the code in this cell, we can click on the run button here. So, here's our print function, and right below that, you can see the output of this function. But note that when you run a cell, this will only execute the code in that cell. In other words, the code in other cells will not be executed. Let me show you what I mean. So in the cell below this cell, I'm going to delete the call to the describe method. Instead, I'm going to print ocean. Now, I'm going to put the cursor back in this cell where we print the hello world message and run this cell. So you can see hello world is displayed here, but the cell below is still displaying the describe table, so we don't see the changes here. Now, to solve this problem, we can go to the cell menu on the top and run all cells together. This can work for small projects, but sometimes you're working with a large data set, so if you want to run all these cells together, it's going to take a lot of time. That is the reason Jupyter saves the output of each cell, so we don't have to rerun that code if it hasn't changed. So this notebook file that we have here includes our source code organized in cells, as well as the output for each cell. That is why it's different from a regular Py file where we only have the source code. Here we also have auto-completion and IntelliSense. So in this cell, let's call df data frame dot. Now, if you press tab, we can see all the attributes and methods in this object. So let's call describe. Now with the cursor on the name of the method, we can press Shift and Tab to see this tooltip that describes what this method does and what parameter it takes. So here in front of signature, you can see the describe method. These are the parameters and their default value. And right below that, you can see the description of what this method does. In this case, it generates descriptive statistics that summarize the central tendency and so on. Similar to VS Code, we can also convert a line to comment by pressing Command and slash on Mac or Control slash on Windows, like this. Now this line is a comment. We can press the same shortcut one more time to remove the comment. So these were some of the most useful shortcuts in Jupyter. Now, over the next few lectures, we're going to work on a real machine learning project. But before we get there, let's delete all the cells here. So we start with only a single empty cell. So here in this cell, first I'm going to press the escape button. Now the cell is blue, so we are in the command mode, and we can delete the cell by pressing D twice. There you go. Now the next cell is activated and it's in the command mode. So let's delete this as well. We have 2 more cells to delete. There you go. And the last one, like this. So now we have an empty notebook with a single cell. Over the next few lectures, we're going to work on a real machine learning project. Imagine we have an online music store. When our users sign up, we ask their age and gender, and based on their profile, we recommend various music albums they're likely to buy. So in this project, we want to use machine learning to increase sales. So we want to build a model. We feed this model with some sample data based on the existing users. Our model will learn the patterns in our data, so we can ask it to make predictions. When a new user signs up, we tell our model, hey, we have a new user with this profile. What is the kind of music that this user is interested in? Our model will say jazz or hip hop or whatever. And based on that, we can make suggestions to the user. So this is the problem we're going to solve. Now back to the list of steps in a machine learning project. First, we need to import our data. Then we should prepare or clean it. Next, we select a machine learning algorithm to build a model. We train our model and ask it to make predictions. And finally, we evaluate our algorithm to see its accuracy. If it's not accurate, we either fine-tune our model or select a different algorithm. So let's focus on the first step. Head over to bit.ly/music-csv. This is a very basic CSV that I've created for this project. It's just some random made-up data. It's not real. So we have a table with 3 columns: age, gender, and genre. Gender can either be 1, which represents a male, or 0, which represents a female. Here I'm making a few assumptions. I'm assuming that men between 20 and 25 like hip-hop, men between 26 and 30 like jazz, and after the age of 30, they like classical music. For women, I'm assuming that if they're between 20 and 25, they like dance music. If they're between 26 and 30, they like acoustic music. And just like men, after the age of 30, they like classical music. Once again, this is a made-up pattern. It's not the representation of the reality. So let's go ahead and download this CSV. Click on this ... icon here and download this file. In my downloads folder, here we have this music.csv. I'm going to drag and drop this onto desktop because that's where I've stored this Hello World notebook. So I want you to put the CSV file right next to your Jupyter notebook. Now back to our notebook, we need to read the CSV file. So just like before, first we need to import the pandas module. So import pandas as PD. And then we'll call pd.read_CSV. And the name of our file is music.csv. As you saw earlier, this returns a data frame, which is a 2-dimensional array similar to an Excel spreadsheet. So let's call that music_data. Now let's inspect this music_data to make sure we loaded everything properly. So run. So here's our data frame. Beautiful. Next, we need to prepare or clean the data. And that's the topic for the next lecture. The second step in a machine learning project is cleaning or preparing the data. And that involves tasks such as removing duplicates, null values, and so on. Now, in this particular data set, we don't have to do any kind of cleaning because we don't have any duplicates. And as you can see, all rows have values for all columns. So we don't have null values. But there is one thing we need to do. We should split this data set into two separate data sets. One with the first two columns, which we refer to as the input set, and the other with the last column, which we refer to as the output set. So when we train a model, we give it two separate data sets, the input set and the output set. The output set, which is in this case the genre column, contains the predictions. So we're telling our model that if we have a user who is 20 years old and is a male, they like hip hop. Once we train our model, then we give it a new input set. For example, we say, hey, we have a new user who is 21 years old and is a male. What is the genre of the music that this user probably likes? As you can see, in our input set, we don't have a sample for a 21-year-old male. So we're going to ask our model to predict that. That is the reason we need to split this data set into two separate sets, input and output. So back to our code. This data frame object has a method called drop. Now, if you put the cursor on the method name and press Shift and Tab, you can see this tooltip. So this is the signature of this drop method. These are the parameters that we can pass here. The parameter we're going to use in this lecture is columns, which is set to none by default. With this parameter, we can specify the columns we want to drop. So in this case, we set columns to an array with one string, genre. Now, this method doesn't actually modify the original data set. In fact, it will create a new data set, but without this column. So by convention, we use a capital X to represent that data set. So capital X equals this expression. Now, let's inspect X. So as you can see, our input set, or X, includes these two columns, age and gender. It doesn't have the output or predictions. Next, we need to create our output set. So once again, we start with our data frame, music data. Using square brackets, we can get all the values in a given column. In this case, genre. Once again, this returns a new data set. By convention, we use a lowercase y to represent that. So that is our output data set. Let's inspect that as well. So in this data set, we only have the predictions or the answers. So we have prepared our data. Next, we need to create a model using an algorithm. The next step is to build a model using a machine learning algorithm. There's so many algorithms out there, and each algorithm has its pros and cons in terms of the performance and accuracy. In this lecture, we're going to use a very simple algorithm called decision tree. Now, the good news is that we don't have to explicitly program these algorithms. They're already implemented for us in a library called scikit-learn. So here on the top, from sklearn.tree, let's import the decision tree classifier. So sklearn is the package that comes with scikit-learn library. This is the most popular machine learning library in Python. In this package, we have a module called tree, and in this module, we have a class called decision tree classifier. This class implements the decision tree algorithm. Okay, so now we need to create a new instance of this class. So at the end, let's create an object called model and set it to a new instance of decision tree classifier, like this. So now we have a model. Next, we need to train it so it learns patterns in the data. And that is pretty easy. We call model.fit. This method takes two data sets, the input set and the output set. So they are capital X and Y. Now finally, we need to ask our model to make a prediction. So we can ask it, what is the kind of music that a 21-year-old male likes? Now, before we do that, let's temporarily inspect our initial data set, that is music data. So look what we got here. As I told you earlier, I've assumed that men between 20 and 25 like hip hop music. But here we only have 3 samples for men aged 20, 23, and 25. We don't have a sample for a 21-year-old male. So if you ask our model to predict the kind of music that a 21-year-old male likes, we expect it to say hip hop. Similarly, I've assumed that women between 20 and 25 like dance music, but we don't have a sample for a 22-year-old female. So once again, if you ask our model to predict the kind of music that a 22-year-old woman likes, we expect it to say dance. So with these assumptions, let's go ahead and ask our model to make predictions. So let's remove the last line. And instead, we're going to call model.predict. This method takes a two-dimensional array. So here's the outer array. In this array, each element is an array. So I'm going to pass another array here. And in this array, I'm going to pass a new input set, a 21-year-old male. So 21, comma 1. That is like a new record in this table. Okay? So this is one input set. Let's pass another input set for a 22-year-old female. So here's another array. Here we add 22, comma 0. So we're asking our model to make two predictions at the same time. We get the result and store it in a variable called predictions. And finally, let's inspect that in our notebook. Run. Look what we got. Our model is saying that a 21-year-old male likes hip hop and a 22-year-old female likes dance music. So our model could successfully make predictions here. Beautiful. But wait a second. Building a model that makes predictions accurately is not always that easy. As I told you earlier, after we build a model, we need to measure its accuracy. And if it's not accurate enough, we should either fine-tune it or build a model using a different algorithm. So in the next lecture, I'm going to show you how to measure the accuracy of a model. In this lecture, I'm going to show you how to measure the accuracy of your models. Now, in order to do so, first we need to split our data set into two sets, one for training and the other for testing. Because right now, we're passing the entire data set for training the model, and we're using two samples for making predictions. That is not enough to calculate the accuracy of a model. A general rule of thumb is to allocate 70 to 80% of our data for training and the other 20 to 30% for testing. Then instead of passing only two samples for making predictions, we can pass the dataset we have for testing, we'll get the predictions, and then we can compare these predictions with the actual values in the test set. Based on that, we can calculate the accuracy. That's really easy. All we have to do is to import a couple of functions and call them in this code. Let me show you. So first on the top, from sklearn.model_selection module, we import a function called train test split. With this function, we can easily split our dataset into two sets for training and testing. Now, right here, after we define X and Y sets, we call this function. So train test split, we give it three arguments, X, Y, and a keyword argument that specifies the size of our test dataset. So test underline size, we set it to 0.2. So we are allocating 20% of our data for testing. Now, this function returns a tuple, so we can unpack it into four variables right here. X underline train, X underline test, Y underline train, and Y underline test. So the first two variables are the input sets for training and testing, and the other are the output sets for training and testing. Now, when training our model, instead of passing the entire dataset, we want to pass only the training dataset. So X underline train and Y underline train. Also, when making predictions, instead of passing these two samples, we pass X underline test. So that is the dataset that contains input values for testing. Now we get the predictions. To calculate the accuracy, we simply have to compare these predictions with the actual values we have in our output set for testing. That is very easy. First, on the top, we need to import a function. So from sklearn.metrics, import accuracy underline score. Now at the very end, we call this function, so accuracy score, and give it two arguments, Y underline test, which contains the expected values, and predictions, which contains the actual values. Now this function returns an accuracy score between 0 to 1. So we can store it here. and simply display it on the console. So let's go ahead and run this program. So the accuracy score is 1 or 100%. But if we run this one more time, we're going to see a different result, because every time we split our data set into training and test sets, we'll have different data sets, because this function randomly picks data for training and testing. Let me show you. So put the cursor in the cell. Now you can see this cell is activated. Note that if you click this button here, it will run this cell and also insert a new cell below this cell. Let me show you. So if I go to the second cell, press the escape button. Now we are in the command mode. Press D twice. Okay, now it's deleted. If we click the run button, you can see this code was executed and now we have a new cell. So if you want to run our first cell multiple times, every time we have to click this and then run it and then click again and run it. It's a little bit tedious. So I show you a shortcut. Activate the first cell and press Control and Enter. This runs the current cell without adding a new cell below it. So back here, let's run it multiple times. Okay, now look, the accuracy dropped to 0.75. It's still good. So the accuracy score here is somewhere between 75% to 100%. But let me show you something. If I change the test size from 0.2 to 0.8, so essentially we're using only 20% of our data for training this model, and we're using the other 80% for testing. Now let's see what happens when we run this cell multiple times. So Control and Enter. Look, the accuracy immediately dropped to 0.4. One more time. Now 46%, 40%, 26%. It's really, really bad. The reason this is happening is because we are using very little data for training this model. This is one of the key concepts in machine learning. The more data we give to our model and the cleaner the data is, we get the better result. So if we have duplicates, irrelevant data, or incomplete values, our model will learn bad patterns in our data. That is why it's really important to clean our data before training our model. Now, let's change this back to 0.2. Run this one more time. Okay, now the accuracy is 1, 75%. Now it dropped to 50%. Again, the reason this is happening is because we don't have enough data. Some machine learning problems require thousands or even millions of samples to train a model. The more complex the problem is, the more data we need. For example, here we're only dealing with a table of 3 columns, but if you want to build a model to tell if a picture is a cat or a dog or a horse or a lion, we'll need millions of pictures. The more animals we want to support, the more pictures we need. In the next lecture, we're going to talk about model persistence. So this is a very basic implementation of building and training a model to make predictions. Now, to simplify things, I have removed all the code that we wrote in the last lecture for calculating the accuracy, because in this lecture, we're going to focus on a different topic. So basically, we import our data set, create a model, train it, and then ask it to make predictions. Now, this piece of code that you see here is not what we want to run every time we have a new user or every time we want to make recommendations to an existing user, because training a model can sometimes be really time consuming. In this example, we're dealing with a very small data set that has only 20 records. But in real applications, we might have a data set with thousands or millions of samples. Training a model for that might take seconds, minutes, or even hours. So that is why model persistence is important. Once in a while, we build and train our model, and then we'll save it to a file. Now, next time we want to make predictions, we simply load the model from the file and ask it to make predictions. That model is already trained. We don't need to retrain it. It's like an intelligent person. So let me show you how to do this. It's very, very easy. On the top, from sklearn.externals module, we import joblib. This joblib object has methods for saving and loading models. So after we train our model, we simply call joblib.dump and give it 2 arguments, our model and the name of the file in which we want to store this model. Let's call that music-recommender.joblib. That's all we have to do. Now, temporarily, I'm going to comment out this line. We don't want to make any predictions. We just want to store our trained model in a file. So Let's run the cell with control and slash. Okay, look, in the output, we have an array that contains the name of our model file. So this is the return value of the dump method. Now back to our desktop, right next to my notebook, you can see our joblib file. This is where our model is stored. It's simply a binary file. Now back to our Jupyter notebook. As I told you before, in a real application, we don't want to train a model every time. So let's comment out these few lines. So I've selected these few lines. On Mac, we can press Command and slash, and on Windows, Control slash. Okay, these lines are commented out. Now this time, instead of dumping our model, we're going to load it. So we call the load method. We don't have the model. We simply pass the name of our model file. This returns our trained model. Now, with these two lines, we can simply make predictions. So earlier we assumed that men between 20 and 25 like hip hop music. Let's print predictions and see if our model is behaving correctly or not. So Control and Enter. There you go. So this is how we persist and load models. Earlier in this section, I told you that decision trees are the easiest to understand, and that's why we started machine learning with decision trees. In this section, we're going to export our model in a visual format. So you will see how this model makes predictions. That is really, really cool. Let me show you. So once again, I've simplified this code. So we simply import our dataset, create input and output sets, create a model, and train it. That's all we are doing. Now, I want you to follow along with me, type everything exactly as I show you in this lecture. Don't worry about what everything means. We're going to come back to it shortly. So on the top, from sklearn, import tree. This object has a method for exporting our decision tree in a graphical format. So after we train our model, let's call tree.export underline graph viz. Now here are a few arguments we need to pass. The first argument is our model. The second is the name of the output file. So here we're going to use keyword arguments because this method takes so many parameters, and we want to selectively pass keyword arguments without worrying about their order. So the parameter we're going to set is out underline file. Let's set this to music-recommender.dot. This is the dot format, which is a graph description language. You'll see that shortly. Now, the other parameter we want to set is feature underline names. We set this to an array of two strings, age and gender. These are the features or the columns of our data set. So they are the properties or features of our data, okay? The other parameter is class names. So class underline names. We should set this to the list of classes or labels we have in our output data set, like hip hop, jazz, classical, and so on. So this Y data set includes all the genres or all the classes of our data, but they're repeated a few times in this data set. So here we call y.unique. This returns the unique list of classes. Now we should sort this alphabetically. So we call the sorted function and pass the result of y.unique. The next parameter is label. We set this to a string all. Once again, don't worry about the details of these parameters. We're going to come back to this shortly. So set label to all, then rounded to true, and finally filled to true. So this is the end result. Now let's run this cell using Control and Enter. Okay. Here we have a new file, music recommender dot. That's a little bit funny. So we want to open this file with VS Code. So drag and drop this into a VS Code window. Okay, here's the dot format. It's a textual language for describing graphs. Now to visualize this graph, we need to install an extension in VS Code. So on the left side, click the extensions panel and search for dot. Look at this second extension here, GraphViz or dot language by Stefan VS. Go ahead and install this extension and then reload VS Code. Once you do that, you can visualize this dot file. So let me close this tab. All right. Look at this dot 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 here on the right side. Click this, you should have a new menu, open preview to the site. So click that. All right, here's the visualization of our decision tree. Let's close the dot file. There you go. This is exactly how our model makes predictions. So we have this binary tree, which means every node can have a maximum of 2 children. On top of each node, we have a condition. If this condition is true, we go to the child node on the left side. Otherwise, we go to the child node on the right side. So let's see what's happening here. The first condition is age less than or equal to 30.5. If this condition is false, that means that user is 30 years or older. So the genre of the music that they're interested in is classical. So here we're classifying people based on their profile. That is the reason we have the word class here. So a user who is 30 years or older belongs to the class of classical, or people who like classical music. Now, what if this condition is true? That means that user is younger than 30. So now we check the gender. If it's less than 0.5, which basically means if it equals to 0, then we're dealing with a female. So we go to the child node here. Now, once again, we have another condition. So we're dealing with a female who is younger than 30. Once again, we need to check their age. So is the age less than 25.5? If that's the case, then that user likes dance music. Otherwise, they like acoustic music. So this is the decision tree that our model uses to make predictions. Now, if you're wondering why we have these floating point numbers like 25.5, these are basically the rules that our model generates based on the patterns that it finds in our data set. As we give our model more data, these rules will change, so they're not always the same. Also, the more columns or more features we have, our decision tree is going to get more complex. Currently, we have only 2 features, age and gender. Now back to our code, let me quickly explain the meaning of all these parameters. We set filled to true, so each box or each node is filled with a color. We set rounded to true, so they have rounded corners. We set labeled to all, so every node has labels that we can read. We set class names to the unique list of genres, and that's for displaying the class for each node right here. And we set feature names to age and gender, so we can see the rules in our nodes.